Oh my goodness, look at this 11 right here. Yeah, that's dirty nasty. Okay, let's see. When we look at this, we're plugging infinity to see what's happening at the different parts of this problem. And if I plug in an infinity into a square root, or a squared, an x squared, it's just going to get infinitely bigger. And if I add an infinite or subtract a 4 times infinite, that's not really going to be bigger than that, but it's still just going to be bigger, and the square root is going to get bigger. I don't know. Here, let me write a little bit more. So if I have an x squared, I'm thinking this. And I think, hey, when I go to infinity, it's going to infinity. When I have a square root, this is what I'm thinking. When we're going to infinity, we're going to infinity. That's going to the right, and it's going up. Okay, so it's going towards infinity. So this is actually infinity right here, and that minus infinity. So if we plug in infinity, we get infinity minus infinity, which is indeterminate. So infinity minus infinity, indeterminate. If we got indeterminate form, that means we have to manipulate this to find our answer. So let's get started here. So the first thing I'm going to do is I'm going to factor out an x squared and inside the square root. And actually, don't write anything yet, because I'm going to show you this. I'm going to show you guys my thinking here, but this is actually the wrong way to do it. And then I'll show you guys the right way to do it. All right, so I factored out an x squared inside the square root. See, what is x squared divided by x squared? That's 1. What is 4x divided by x squared? That's going to be 4 over x. And the reason why I'm doing that is now I can take an x squared out of this. And so I get x squared, the square root of x squared, and then I have 1 minus 4 over x. Okay, and then we're subtracting x out here, and then this will simplify down. What is the square root of x squared? That's just an x. And then I have 1 minus 4 over x, and then minus x. Okay, this is going to be, I'm going to now factor out an x. So if I factor out an x, this is what I get. That shouldn't be a 4. Let's scribble that out and write the correct number there. That should be an x. And after I take out the x, this is what I get. And so I thought, okay, I'm going to try to approach infinity with this result. And I almost get somewhere. You see, this x is going to be infinity. This fraction is going to go to 0 because the x is on the denominator. And so I get left with this, which I'm almost getting somewhere right here. It says the square root of 1 minus 1, which is 0. Now, if you had infinity minus 0, or infinity times 0, that is an indeterminate form. It does not equal 0. So we got an indeterminate form going this way, unfortunately, so I had to try to attack this a different way. So this is gone. So the other way, this is the correct way that I thought about doing this, is by taking what we started with, and I'm going to make it into a fraction. Why am I making it into a fraction? Because I know that if I multiply by the conjugate, it'll change the way this thing looks. So I'm going to multiply the top by the square root of x minus 4x plus x. And this is going to change the way things look. So let's do that to the top and the bottom and see what we get. Okay, and I'm going to take a shortcut for the top because they're exactly the same except for the sign. I know this is going to give me a difference of squares when I'm done. So I just have to square the first term minus and square the second term. So I square the first term and I get x squared minus 4x. And then I square the second term, I get x squared. So this is minus because it's a difference of 2 perfect squares. And then I have my denominator, just writing that out, times 1. Okay. And then top, something cool happens. These x squareds go away. So after those x squareds go away, I'm left with 4x on the top, negative 4x on the top. And the bottom, I can factor and then start simplifying some stuff. So we just did this before earlier. I took out an x squared from the inside of the square root. That's what's happening right here. When I factor out the x squared, I'm left with 1 minus 4 over x. So I divided that by x squared. And I divided 4x by x squared. What's the square root of x squared? That is x. So this is your plus x. And since this is an x, I can now take out an x from each of these terms. And this is what it now looks like. So in short, what just happened was I looked at the denominator and I took out an x. I took out an x, this is what I got. How did I know to take out an x? I first took out an x squared from this first one, and then it simplified down. Okay, so Now I'm going to find the limit as x approaches infinity of 4x over x times that. And hopefully you guys can see I can cancel out these x's right here, which is nice. So I'm going to cancel those guys out. And look what I get. Negative 4 on top. And the bottom, when I plug infinity into that, what happens when you have infinity on the denominator?
0.
It goes 0, which is a beautiful thing. So now I have the square root of 1 plus 1. Square root of 1 is 1, right? And I had negative 4 divided by 2, which equals negative 2. And that's your result. So this is a horizontal asymptote at negative 2. That's your answer.
When did you get rid of
Good question. Going back, how did this x become a 1?
Yeah.
I'm looking at each of these like their own term, like this guy and this guy. And so I divided this and this by x, and I put them out here. So I'm factoring out that x. X divided by x, that's how I get this 1. And when I take the x out of this term, that x is no longer outside the square root right there. So if I distribute this x back out, I'll get right back to where I was. Does that make sense?
Yeah.